what's called geometric sequences. And if you remember, we have already done arithmetic sequences. And arithmetic is if you could find an add subtract. Whoops. Again, if you could find an add subtract sequence. So for example, if you had something like 2, 6, 10, 14, you can see that each time it's just adding 4. So arithmetic is if it's addition or subtraction. And we always list it as addition, so you can always list it as like adding a negative. But if you can find an add or subtract pattern, then and the pattern does have to be constant, then it's arithmetic. So geometric then goes to multiplication. So geometric sequences simply means that you can see a multiply or division, which we could rewrite as multiplication as well, but multiply or divide pattern. So for example, if we have something like this, 120, 60, 30, 15. Well, clearly you can see that this is just dividing by 2, or if you can't, we're just taking half of each of those. So divide by 2, divide by 2, divide by 2. However, when you have a sequence, you try and find what's called the common ratio. So the common ratio or the common difference always has to be in multiplication. So if you would go, for example, and put on Big Ideas, divide by 2 as the pattern, they would count it wrong because they want you to think in terms of multiplication. So instead of dividing by 2, you could simply multiply by 1/2. And that would be the exact same thing, but that would be you putting in the common ratio as multiplication. So times by 1/2 would get you to 60. Times by 1/2 would get you to 30. So anytime you're trying to find a common ratio, you are looking for how is it being multiplied. Same thing with arithmetic, it would have to be addition. So we would just use the negative. So again, common ratio has to be the pattern in multiplication. All right, these next examples, you are going to have to determine if the pattern is arithmetic, geometric, or neither. So you will be given, for example, something like this: 2, 6, 11, 17. That'd be example 1. The second one we'll do 5, 1, -3, -7. And the last one we will do 128, 16, 2, and 1/4. So again, looking at this first one, we're looking to see what's happening. Well, it looks like addition, but it looks like here we're adding 4, here we're adding 5, and here we're adding 6. So even though, like, I could technically find the pattern, this is not arithmetic because it's not a constant. Remember down here it would have to be like +4, +4, +4, and it's not. So this would actually be neither. This next one, 5 down to 1, looks like -4, -4, and -4. So this is arithmetic because it's add or subtract. And this one down here, I'm not really sure what 128 to 16 is, but I'm going to go out and say, okay, this is divide by 8. This is divide by 8. So I can go back and check on my calculator that this must also be divide by 8. So remember, when you're listing a common difference, really it would be times by 1/8, times by 1/8, and times by 1/8. So this one would be geometric. The next thing you may have to do is actually find the next 3 terms. So in order to do that, you will obviously need to find the pattern first, and then you will have to just tell me the next 3 terms. So for example, if I said 3, 6, 12, 24, give me the next 3, you would first have to figure out what is the actual pattern. So I can see here that the pattern is times by 2, times by 2, times by 2. So all I need to list is the next three numbers. So 24 times 2 would be 48. 48 times 2 would be 96. And 96 times 2 would be 192, I believe. Yes. If they actually have you graph a sequence, you can actually graph a sequence on a coordinate plane. And really what you just have to do is you just have to kind of add an x to it. So for example, if I have 16, 8, 4, 2, these are kind of like the outputs, like the y's, and you could just add an x up here and say, okay, well the first number is 16, the second number is 8, the third number is 4, the fourth number is 2. So those become your ordered pairs, 1, 16. So go over 1, and let's say that this is 16 up here. Then 2, 8. So over 2, up 8. Then 3, 4, over 3, up 4. And then over 4, up 2. If we want another one, this would be a 1, this would be a 5. So over 5, up 1. You can see what's happening is an exponential function. So if you do ever have to graph it, it will probably form an exponential function. The last thing you may have to do is find what's called the nth term, and it just means that I could tell you any term. Like if I said find the 10th number, or find the 50th number, or find whatever, you could put this into a formula and find it. So you're going to want to write this formula down. It is a to the n, which just means, or a sub n, which just means the nth term. And you use a1, which I'll tell you what all this stands for, r, and then n minus 1 up here. So a to the 1 just means the first term. You just put that number in there. The r is the common ratio. Remember that thing that we figured out, what was it being multiplied by? What was the pattern? And then the n is just the term. So this is the term, and this is the term. So, for example, if I said 2, 12, 72, 432, and it said find the, let's go 10th term. Okay, well, obviously you could just keep multiplying times by whatever once you figure it out. And it looks like times by 6, times by 6, times by 6. So sure, you could just keep multiplying, but know that you could also put it into your equation up here. So let's just rewrite it. A to the n, well, it's going to be the 10th term. So I'm going to just I'm just writing this, but now I'm going to put 10s in there. So a to the first, right here, just means what is our first term? So our first term is a 2. So you replace that. What is the ratio? The 6, because that's what's happening each time, times by 6. 6. And then it's all raised to the, what term do we want? 10. 10 minus 1. So, again, it's all about order of operations. So you're going to take 6 to the 9th power, and then go back and take it times 2. So when I take 6 to the 9th power on my calculator, I already get 10,077,696, and then you still have to take that times 2. So when you take that times 2, you get 20,155,392, and that would be your 10th term. And again, you could just keep going down here and do times 6, times 6, times 6. But this formula is nice if you don't want to have to type all of that in. So that's finding the nth term, which means I could give you any term. Find the 10th term, find the 6th term, find the 5th term. So a to the 1 just is what is the first number in your pattern, and the r is the common ratio.